Continuing with buildings and cities, we'll look at green roofs briefly again. It's ranked at number 73 by 2050 with a saving of 0.77 gigatons in reduced CO2. The cost, net cost, is $1.39 trillion, which sounds high, but we will see that there is a lifetime saving that's much more significant. The net savings here by 2050 are calculated at $988.5 billion. Yes, the green roofs are expensive. The design, the weight-bearing capacity, the various drainage systems, and so on. But one has to look at all the other direct and indirect benefits as well. This is an example designed by Dr. Stefan Brenneisen, the green roof of the Cantonal Hospital in Basel, Switzerland, overlooking the town and the Rhine River down there. Constructed in 1937, the building welcomed its first green roof in 1990, which mimics the riverbank of the Rhine in design. Okay, so you can see a little bit there, but that's supposed to emulate that. The vegetated roof features two gravel areas to attract birds, as well as areas of sedum, herbs, moss, and large grass meadows. So various biodiversity kind of accommodations are also made. It's interspersed with big branches and stones to provide cover and is monitored for birds, spiders, beetles, ladybugs, bumblebees, and more. So it's just a little forest cover there by itself. Here's an example from Flickr. These are called Tortvak, I think, which means surf roof. So this apparently was a tradition even going back to the Vikings times in the Scandinavian countries, and then maybe disappeared and now is being brought back. So you can see the beautiful green roof here with some solar panel there and so on. So who wouldn't want to live in such a wonderful place? All right. This is from the Columbia University Center for Climate Systems Research, showing an example of surface temperatures with the traditional black roof versus the green roof, and you can see tremendous differences in the surface temperatures, and you can imagine how much difference that makes for the cooling bills and the extra need for heating in the winter is supposedly more than offset by the summer cooling temperatures. And if you think of this at a scale of a city, you can imagine how much urban heat island is going to be reduced. So in a concentrated building neighborhood of a city, one green roof can benefit a lot of the neighbors as well. Also from Columbia University is an example of various parameters compared here for Plan NYC Stormwater Management Report of 2008 versus Columbia NASA study. So that's NASA Goddard Institute for Space Studies, which sits on campus in Columbia. Gallons retained per square feet is 0.47 for the storm management planning, whereas it's 10.2 gallons per square foot when you do a green roof. Cost to capture a gallon is dropped from $133.37 from the stormwater management to just $2.43 for the green roof. Annual cost per gallon from $3.33 down to $0.002, it's just 2 cents, and cost per year per square foot is at $1.56 for traditional stormwater management system, whereas it's just 20 cents for the green roof, and it's pretty amazing cost savings there. So green roofs have huge advantages, social amenities for the building, heating and cooling bills, and just the beauty of the whole city center and so on. Doesn't have to be just in the cities, but here we are specifically talking about buildings and cities. The other concept is called cool roof, which is slightly different than the green roof. So it focuses more on solar reflectance as well as thermal emittance. So when you have sun's radiation hitting the roof material will absorb some and is transferred to the building below, and there is some reflectance. So if you have a black roof or various types of tin roofs, tiles, etc., you have various levels of albedo. The cool roofs basically try to manage the direct albedo, so the reflectance of the shortwave radiation that's incident during the day, as well as the thermal emittance, which is the long wave radiation being emitted by the roof material. So there is relative ability of the roof surface to radiate the absorbed heat. And now there are also concepts of changing slopes and managing the seasonality of the energy requirements to be lost or retained from the roofs. This is a figure from that same site, nrdc.org. It's looking at the comparison of the albedo. In a warm roof, you have only about 20% being reflected, whereas if you take a cool roof, you can increase the reflectance of solar radiation by 80%, and then you can also add the thermal emittance properties of the material that's used to add further energy management. Obviously, another no-regret solution. So, overall impacts. In modeling green and cool roofs, we account for regional applications of each technology. Depends on climate, depends on cooling and warming requirements seasonally, and so on. If green roofs cover 30% of roof space by 2050 and cool roofs over 60%, a total of 407 billion square feet of efficient roofing would be in place globally. Combined, these technologies could reduce carbon dioxide emissions by 0.8 gigatons at a cost of $1.4 trillion. There is indirect energy savings, of course, and emissions reductions indirectly. 30-year savings of $988 billion and a lifetime saving of $3 trillion. Okay, so this is clearly a good part of the drawdown solutions that we want to consider overall.